Okay, so friends, we are here gathered to learn about the 7th grade Olympiad maths topics. I am Dr. Hina and I am going to teach you the basic concepts and we'll solve the examples together. So, our today's topic is rational numbers. So, what is mean by numbers? 1, 2, 3, 4, 5, 6, 7, or what a continue up to the infinity, whatever we use to count the things, to represent the number of things, we use numbers. Numbers are of so many types: natural number, whole number, integers. We already learn about them. Natural number always starts with 1, 2, 3, 4 and goes up to the infinity. Natural numbers, all natural numbers are positive numbers. Okay. Then whole number, if we add 0 into the natural number or we start from the 0, then it is known as whole number. 0, 1, 2, 3, 4 up to the infinity. And integers, all negative positive together, is called as integers. They are infinity at both the sides. That only given in the introduction section, that we already know about the integers, the fractions, decimals and their operations. We know that the given integer a and b, their addition, subtraction, multiplication are always an integer, but the result of the division of an integer by non-negative integer may or may not be the integer. Okay, it can be decimal also. So we know about their operations, their addition, their subtraction in the last topic about the integers. Now suppose if a number is in the form a upon b, okay, where b is not equal to 0, then it is called as rational number. Okay, that a and b can be positive or negative positive, but denominator should not be 0. If this condition is fulfilled, the number is called as rational number. If numerator is 0, then also the number is called as rational number, because 0 is also a rational number. Okay. Now every natural number is a rational number, but the rational number may or may not be a natural number, because answer can be negative. Every whole number is a rational number, but again the rational number may or may not be the whole number. Every integer is a rational number, but the rational number may or may not be an integer, which we already learned. Now, what are the types of rational numbers? Rational numbers are of two types. They are maybe positive or they are negative. What is meant by positive rational number? So, if the numerator and denominator of the rational number having same sign, okay, then it is a positive rational number. We know positive if they are in multiplication, if they are in division, two positive numbers, their product or their division ka result is always a positive. Negative also gives the positive result. So if the numerator and denominator have same sign, means we don't have positive negative numerator denominator. Like if the numerator is negative, denominator is positive, the answer is not a positive rational number, it is a negative rational number as an answer. So both the numerator and denominator should have same sign, either positive or negative. If they have different sign, then the number is said to be negative rational number. Okay. Now 0 is also a rational number, but 0 is non-negative, non-positive rational number. It is not included either in positive numbers or nor in negative numbers. Now properties of rational number we have to learn. As we had done the operations on integers, multiplication, division, everything, same way we can do the operations on rational numbers also. Rational number, one second. Okay, the rational number remain unaltered. Okay, if we multiply the numerator and denominator by same non-zero number. If x upon y is a rational number, if we multiply this x and this y with the same non-zero, okay, why? Because if we multiplied by 0 and we multiply the numerator by 0, answer will be 0. Denominator answer is also 0, but we know the condition of rational number. If denominator is 0, it is not a rational number. So it should be multiplied by non-zero same number to the denominator and numerator, then the rational number remains unaltered. A rational number remains same if we divide a numerator by the same non-zero rational number. If we multiply or if we divide, we get the same rational number, which is equivalent rational number, we can say. Okay, so if we multiply and divide the numerator and denominator of a rational number by the same non-zero integer, then we get equivalent rational number. So by dividing and by multiplying with the same non-zero number to the denominator and numerator of the rational number, we get its equivalent rational numbers. Okay. Now if we want the lowest form of the rational number, then what we have to do? So divide the numerator and denominator by HCF, highest common factor of the numerator and denominator, by ignoring the sign of it. So we get the new numerator and denominator which are co-prime of each other. Okay, they are equivalent to each other, and it is the lowest form of that rational number. See, 60 upon 96, but minus 60 upon 96 is one of the rational number, and the highest common factor of both of them is 12, because 60 is also coming in the table of 12 and 96 is also coming in the table of 12. So if we divide the numerator and denominator by 12, we get the new rational number, that is minus 5 by 8, which is the lowest form. It is equivalent to this, but it is the lowest form, simplified form of this rational number. So by finding the HCF of numerator and denominator, we get the lowest form of that rational number. Okay. Now what is meant by standard form of the rational number? In the standard form, we always write denominator as a positive. For this, if denominator of a rational number is negative, then we multiply it with the minus 1. So we get the positive denominator. So it is known as standard form of the rational number. Okay. Denominator should be positive. Numerator may be or may not be positive, but denominator should always be positive in the standard form of the natural number. Rational numbers, if we want lowest form, then we have to first find the highest common factor of numerator and denominator, and we have to divide with that number to both numerator and denominator. We get the lowest form of that rational number. Now comparison of the rational numbers. Write the rational numbers in the standard form. Every positive rational number is greater than the negative rational number. Okay, we know na 1 is greater than minus 2. Even if it is a 2, but 1 is greater than minus 2, because minus 2 is on negative side. So negative numbers are always smaller than positive numbers. By making the denominator same by shortcut method, multiplying it with -1, compare, when we have to compare the rational number, first what we need to do is, first we have to make its denominator positive, that is convert it into the standard form. Find the LCM of all denominators, least common multiple we have to find. Here we don't want lowest form, so we are not going to calculate here highest common factor. We are calculating the LCM, least common multiple of all denominators. Why? When denominator is same, we can compare the numerator, and whose numerator is greater, that number is greater, and we can arrange them on the ascending order or in the descending order. So one example is given. Arrange the following rational number in the ascending form. So here two rational number have negative denominator. So first we have to make their denominator positive by multiplying numerator and denominator by -1. So the first number become -3 upon 5. Second number become 5 upon 7. Third number is -4 upon 15. And the fourth number is 7 upon 15. Now the highest common factor of all the denominator is 105. Okay, so all denominator to become 105, we have to multiply here 3 with 35. Okay, so we have to convert one number. Okay, because we are not going to add them here, so we have to convert them. So first 3 upon 5, -3 upon 5, 5 by 7, 4 upon 15, -4 upon 15, and 7 by 15. These are our numbers, and their HCF is 105. So this denominator to become 105, we have to multiply it with 21. 21 multiplied by 5 and -3 multiplied by 21. We have to multiply with the same number. Again here we have to multiply the 7 with 15, 5 with also 15. Here same, -4 multiplied by 15, 7 is 105. So 15 is also multiplied with the 7, and 7 multiplied by 7 and 15 multiplied by 7. So all the denominators will become 105. So we can compare the numerator easily. So first rational number become 21 3s are -63 upon 105. Second number will be 75 upon 105. Third number will be 28 upon 105. And 49 upon 105. Now here don't do the mistake of giving their sign, because if you don't give sign to these numbers, 63 is bigger than 28. Okay, 49 is lesser than 63, but 63 is negative, 49 is a positive, 28 is negative. So if we have to arrange in ascending order, we have to take the smallest number first. So here smallest one is -63 upon 105. That is, this first number is the smallest one. So it will come first. Then greater than that is -28 upon 105. That is this one comes at second place. Then 49 upon 105. This is third one, and this is fourth one. This is the highest number, or this is the greatest number. Same way they have solved here. See, LCM we have to calculate least common multiple, and then we have to arrange the numerator, and we can arrange them in the form of ascending order. Highest common factor we calculate to get the lowest form of the rational number, and LCM of all the rational number we calculate to compare them with each other. Shortcut method is also there. Write the rational number in a standard form, means denominator should be positive. Multiply the numerator of the first rational number with the denominator of the second, and vice versa. This is when we compare in between two rational numbers only. So if AD is greater than this BC, A upon B, the first number is greater than the second number. If AD is lesser than BC, then the second number is greatest one. And this comparison we can do in between two numbers only. Okay. Now which one of the two fraction is greater? So here again we have to compare in between only two numbers. See, we don't have so many number 3, 4, something like that. So we don't need to do or don't need to find here LCM of both the numbers. We just what we'll do, first convert it into the standard form and we'll do cross multiplication. Okay, so convert it into standard form by multiplying numerator and denominator with 1. Now cross multiply. 7 minus 7 multiplied by 7 is equal to 49. So if this is A upon B, this is C upon D. Product A D is 49 and BC is 6 8s are 48. But see, both the number have minus sign. Though 49, positive 49 is greater than positive 48. But here minus 48 is greater than minus 49. So here BC is greater than AD. So 6 upon minus 7 is greater than minus 7 upon 8. Okay. Understood? We had done, first we convert it into standard form, then we do cross multiplication, and we know if if AD is greater than BC, then the first number is greater than the second one. If BC is greater than AD, then the second number is greater than first number. Now see, in the first step they had converted the rational number into the standard form, then we had find out the products of both AD and BC. Now 48 is greater, so 6 upon 7, the second number is greater than the first number. Now operation of rational number, we have to add, we have to subtract, we have to multiply, we have to divide the rational number. Then what are the steps? Write the number in a standard form. Make the denominator same by taking LCM of it. What we are doing to compare them, same we have to do. And write all the rational number with the same denominator. Add them or subtract them. Write the numerator getting after addition on the denominator and reduce the rational number to lowest form. To reduce it to lowest form, we have to find their HCF, but HCF of numerator and denominator, not the denominator of all. For denominator of all, we always calculate least common multiple of all the denominators. Now see, here are some numbers and we have to add them. Now the given national number, we have to convert it in a standard form. So we had converted it. 5 2s are 10, plus 3, 13, 13 upon 5 the first number, minus 15 upon 13 second number, minus 13 minus 15. So if we multiply by minus 1 at numerator and denominator, the number becomes 13 upon 15 because we have to convert it into standard form. And 4 are 20 plus 3 23, so minus 23 upon 5. These are the four numbers. Now what we have to do? We have to calculate first the LCM of all the four denominators. So it is 195. Now denominator to be 195, we have to multiply first rational number with the number 39. We get this number. Second rational number with 15. We got our second rational equivalent number. Third also with the 13 and fourth with 39. We get these four new equivalent rational numbers whose denominator is same. Now what you have to do is you have to just add the numerator. 507 minus 225 plus 169 minus 897. If we add four of them, we get minus 446 as an answer and just simplify it. Okay. So we have added the numbers. To subtract, again convert it into standard form, find the LCM of all the denominators, subtract the numerator, and whatever result we got, we have to convert it into its lowest form. Okay, the same way. Now here both the number are in the standard form. We just have to calculate their least common multiple and we have to just subtract the numerator. So 16 and 20 is the common multiple is 80 because 80 is in the table of 16 also or in the table of 20 also. So the LCM of both the number is 80. Now first number to become 80, we have to multiply both numerator and denominator with 5, and second number to become 80, we have to multiply the numerator and denominator with number 4, and we get our new numbers, that is minus 25 upon 80 minus 36 upon 20. Now 80. Now minus 25 minus of minus 36 upon 80. When minus of minus is there, minus minus become plus, so it is 36 become plus, or you can write 36 minus 25, or you can write minus 25 plus 36. So anyways we have to subtract 25 from 36. So we get 11 upon 80 as a answer. Multiplication, product of numerator and product of denominator we have to do and reduce it to lowest form. Reciprocal of the rational number. Now for non-zero numbers, rational number is said to be the reciprocal of other if the product is this one. Means what? So first we have to find the product of it. Multiply the numerator, multiply the denominator, we can find the product. Now we have to find the reciprocal. So simplify the rational number 4 by doing simplification method. You can use 4 1 ja 4, 4 2 ja 8, 3 1 ja 3, 3 3 ja 9. Now we cannot further simplify it, so minus 1 it is. Minus 7 minus 1 becomes plus 7 upon 13 2 ja 26 and 26 3 ja 78. Now this is our product, and answer is 7 upon 78. So if we have to find the reciprocal of it, we know its product is 1. So 78 upon 7, if we take, then 7 7 cancel, 78 will get cancelled, so their product is 1. So to find the reciprocal, what we have to do, simply just change the position of numerator and denominator. But if we have to do first operation like multiplication, division, and then we have to find the product, then first solve the example, and while getting its reciprocal, you just change the position of numerator and denominator and you get its reciprocal. Okay, means what? If I have a rational number 7 upon 3, what is the reciprocal of 7 upon 3? So it is 3 by 7, because their multiplication is always 1. Okay, so 7 upon 3 ka reciprocal is 3 upon 7. Now product of two rational number is 23 upon 88 minus 23 upon 88. If one of the number is 5 by 22, then find the other rational number. So assume first rational number as a, and if it is multiplied by minus 23 upon 88, we get the product 5 upon 22. Okay, now this a or this 23 upon 88 is in multiplication here. So while going to other side, it will go to the division. So it becomes 5 upon 22 divided by minus 23 upon 88. And when we divide with rational number, we can multiply with its reciprocal. So it becomes 5 upon 22 multiplied by 88 upon minus 23. So 22 1s are 22, 22 4s are 88. Now 5 and 23 cannot be multiplied with each other. So we can say 20 upon minus 23 is our another number, which when multiplied with this number, we get this product. See, product of two number is equal to minus 23 upon 88 multiplied by that number is equal to 5 by 22. Now this minus 23 upon 22 will go to the division side, or 5 by 22 will come to the division side. Okay, so when we divide rational number with the rational number, we can multiply with its reciprocal. So we take the reciprocal of 5 upon 22, that is 22 upon 5. So our another number is minus 23 upon 20. Okay, clear? Now we look into some of the solved problems, and then we'll solve the exercise. Now see, there are some rational number and we have to arrange in a descending order. So our first step is convert it into standard form. So to convert it into the standard form, what we have to do is make the denominator positive. Okay, and after doing this, we have to find the least common multiple of all these four numbers. So all these four numbers ka least common multiple is 30 only, because 31 are 30, 5 6 are 30, 15 2 are 30. So every denominator should be 30, or to make every denominator 30, we have to multiply with some numbers to the numerator. So for the first number, we no need to multiply with anything, so we just multiplied with 1, so the number will remain as it is 17 upon 30. Second number become 18 upon 30. Third number will become 8 upon 30, but it is minus 8 upon 30. And the fourth number will become minus 14 upon 30. Now we have to arrange in a descending order. So first we have to take the bigger number. So which is bigger number here? 18 upon 30, because 18 is greater than 17. 17 is greater than minus 8, and minus 8 is greater than minus 14, because though the 14 is greater than 8, but while uh, while thinking about minus sign, minus in the minus integers, bigger number is smaller and smaller number is bigger. Okay, so minus 8 is greater than minus 14, and likewise you can arrange. So this is first, this will come first, then second is this one, third one is this one, and fourth one is this. Okay, so just remember the steps, or just keep in mind the steps, that we have to first convert it into standard form, then we have to find the least common multiple of all the numbers, then we just arrange the we just find the equivalent rational number, and then we arrange them in the descending order. Now if for three rational number x, y, z, such that x is greater than y, y is lesser than z, which one of the following is true? So y is the smallest rational number, it is true. Because we don't know whether x is less than z or not. Because see, if x is 8, y is 2, x is greater than y. Okay, but z is 4, still z is greater than y, but z is not greater than x. So the true statement here is y is the smallest rational number only. Okay, now prefer defines rational number in the following ways. It is of the form p upon q, where q is the smallest whole number. So smallest whole number is 0, and it is not possible, because 0 cannot be a denominator in the condition of rational number. So this p upon q is not a rational number. Now which one of the following statement is true? Equivalent of p and q is different from p upon q. Now 35 upon p, 33 upon q is equivalent to p and q. See, this is not true, because we have to multiply denominator and numerator with the same number to find its equivalent. Okay, so this statement is false. There are only 5 equivalent rational numbers of the form p upon q. This is also form we get innumerous, matlab we uncountable equivalent forms of the rational number. Okay, so we can write infinite equivalent rational numbers of the form p and q is the correct answer, true statement. So likewise you can go through the solved examples, and after you revise the topic or going through the solved examples, in the next class we'll move to the practice exercise. Okay, till then have a good day, we'll meet soon.